Welcome to the Mastering the SolarEdge TerraMax 330 kilowatt inverter webinar. My name is Frank McIntyre, Senior Applications Engineer for SolarEdge. Today we'll learn more about SolarEdge's new offering for community solar projects in particular, but also this product is good for agri-PV, carport projects, and small to medium-sized utility sites. The TerraMax is a 330 kilowatt DC optimized inverter solution based on 1500 volt DC topology that utilizes SolarEdge's familiar optimizers and highly efficient inverters. Let's get started. Some specifications and features that are important. On a high level, the inverter is rated at 330 kilowatts AC. That makes it one of the highest rated inverters on the market. It's a 1500 volt DC inverter. During operation, it uses a fixed input voltage of 1250 volts DC. The AC voltage is 690 volts AC. That makes it an 800 volt class rated inverter. The inverter measures 43 inches wide by 36 inches tall, and it weighs 386 pounds. Grid connection is 3-wire, and you can put 200% oversizing on the DC side up to 660 kilowatts. Communication options are CAN bus between inverters, RS-485 Modbus, Ethernet and cellular for external devices. It carries all the smart inverter certifications that you would expect, like UL 1741SB and the latest IEEE 1547 grid interconnection requirements. It also includes features like PID mitigation, and it's also ready for storage. It has features like commissioning from the sun that allow you to commission the inverter with the DC side when you don't have AC present at the site. And it also features central commissioning where you can commission a group of inverters all together. For illustration purposes, we've flipped the inverter on its back. Here you can see what the bottom of the inverter looks like. From right to left, you can see the two AC conduit plates. You can see the DC conduit plate, the DC switch, the pairing switch, which is used to pair the optimizers and to put the inverter into service, and the communications module. Also, you can see the 6 fans on the bottom that are used to help cool the inverter, and these are field replaceable. Entry into the inverter enclosure can be done with conduit or with cable glands. This is what it looks like with conduit, and you can use also something like this, a cable gland. The AC conduit size is up to 2.5 inches on both of these conduit plates, and for the DC side, those up to 2 3-inch conduits. Now that we've seen what the bottom of the inverter looks like, we've flipped it back up, and for our example, we've installed 2-inch conduit on both the AC side and the DC side. Now let's take the cover off and have a look inside. All right, now that we have the cover off, let's take a look inside and see what some of these components are and how you interact with them. So on this side right here is the AC terminal blocks. This is a dual terminal block for connecting parallel circuits, up to 2 circuits. Up to 600 kc mil conductor, either copper or aluminum. Down here is the ground terminal bus bar. Here are the AC surge protection devices. Moving over here, you see the DC surge protection devices, 2 fans that are field replaceable, and auxiliary fuses for the auxiliary communications board. In the center portion is the DC terminal block. It too is a dual terminal block, up to 600 kc mil conductor, either copper or aluminum. Here's the ground bus bar for the DC side. You can connect one large combiner with large conductors on the DC terminal block, or you can connect a large combiner with 2 circuits coming out, parallel circuits, on the dual terminal block. Or you could have 2 smaller combiner boxes connected individually to the dual terminal block on the DC side. And lastly, there is the AC contactor lockout switch that has to be removed from its shipping position by unscrewing this screw and moving it over into the operation position. Now that we've looked at all of the different components inside, and what they look like and how you interact with them, we've went ahead and pulled in our conductors, and we've made our terminations, and we've landed the conductors on the terminal blocks. We've left off these two so that we can illustrate how that's done. So here on the AC side, we have the one conductor still ready to land. It's a good time for us to talk a little bit about the compression lugs that are used and the conductor. So this terminal block can accept up to 600 kc mil conductor, each one, either copper or aluminum. The compression lugs have to be at the most 1.77 inches wide, and the thickness is at the most ½ an inch thick. The bolt hole size is ½ inch. You land the conductor on the threaded stud. You seat the compression lug on the terminal. Then you put in your first washer, flat washer, then the Belleville washer, and you have to make sure you put it on properly because it's directional. And then you put on your 18 millimeter bolt or nut. Then we torque it down to 310 inch-pounds. We're going to do the same thing on the DC side now. Same specifications for the conductors, for the compression lugs, up to 600 kc mil conductors on both terminals. It can be copper or aluminum. The compression lug again can be at the most 1.77 inches wide, ½ an inch thick, and with a ½ inch bolt hole. You seat the conductor with its compression lug on the threaded stud, and you seat it on the terminal block. You take your flat washer and your Belleville washer, making sure you put it on correctly, and then your 18 millimeter nut. Torque down to 310 inch-pounds. Then you reinstall your covers. By the way, all the specifications for your compression lugs, for your conductors, and for the torque values are found on this cover. Same thing on the DC side. All of the specs for the compression lugs, the conductors, and all of your torque values are here. Now that's all there is to making the electrical connections. Now we can put the lid back on.
In this video, we'll see how to quickly design a ground mount system using the SolarEdge TerraMax 330 kilowatt inverter. The first step is to go into SolarEdge Designer and create a commercial site design. To do this, click on the Create Project dropdown and select Commercial Project. On this page, you'll fill in the specific project details of the site, starting with the project name and address. Google has recommended the address for this site in satellite view. You can see the defined draw area within the blue square. We're going to move the red pin and zoom out a little bit to better define the draw canvas to ensure we have ample room for the array. The next thing to do is select the grid parameters. From the electricity grid drop-down menu, you'll need to select the grid type. For the TerraMax inverter, it's 690 volts. Once all of this information is filled out, click the Create button at the bottom of the screen. Now we can begin to design our site by going down the list of tabs on the left side of the screen. The first tab is the Consumption button. For this example, we're going to leave this blank. If the site is behind the meter and you're offsetting a load, you could put your load profile here under the Consumption profile, and the system will figure out your production versus consumption data. Now let's go to the Site Modeling panel on the left side of the screen. This is where you actually draw the area that you're going to put the solar array in. Notice the various tools at the top of the page. We're going to select the Draw feature. That's what we'll use to draw the lines and the perimeter of the site array. I'm going to create a rectangular area for the array here. You'll notice that as you draw the lines, the two lines will turn green, indicating that they're parallel to each other, and the small squares in the corner indicate that it's square. The next step is to select the PV module placement panel. This is where you select the PV module that you want to use. Now you'll click the Add PV Modules tool at the top, and this panel pops out. Here you can select the module type. Now that you've selected the module type, you can change a number of different things regarding the placement of the panels, orientation, racking, etc. These are the default settings, but for our example, let's change the orientation to portrait. We'll leave the azimuth pointing due south at 180 degrees and a 10-degree tilt angle, but you'll want to make sure that you use the optimal tilt and azimuth for your site. We'll change the frame size to 2. That means 2 modules, one above the other. Column spacing, which is the distance between modules, we'll leave at 0.79 inches. For row spacing, we'll use 144 inches, or 12 feet in between rows. Now that we've input all of our placement information, we'll click and drag over the area of interest to place the array. Next, we'll click on the Electrical Design tab. The system will automatically give you the optimal inverter and optimizer combination based on the grid parameters we selected earlier, which was 690 volts. Now that Designer has given us a valid design, the next step is to click the Generate button at the bottom of the Electrical Design tab and start stringing the array. On the right side, this box shows us how many inverters have been added to this design. We're going to click Select All and then click the Auto Stringing tool at the top. The Electrical Design tab will open and provide details for how many strings for each inverter. Click the Generate button again. If you have a valid design, you'll receive a confirmation that auto stringing was performed successfully, and you'll see little green check marks next to all of the optimizers on the right side of the screen. If you see any red flags next to the optimizers or inverters on the right side of the screen, you'll need to adjust your design and generate it again. If you click on any of the inverters, they're all color-coded, so you know which ones you're looking at, or you can click on a single string. Now that you've generated a valid design, you can click on the Summary and Reports button. This page provides a project summary with a bill of materials, the design, some production numbers, and charted graphics. Under the Project Layout tab, you can also download the PDF or the DXF file of the string layout. Lastly, you'll want to go to the Export tab at the bottom of the menu on the left to export this design directly to the monitoring platform. This is an important step for a couple reasons. One, You must have the system in the monitoring platform in order for SolarEdge to honor the warranty and support the system. 2. Exporting the site design to the monitoring platform before you build it saves you time in the field because the crew can automatically map the site using Sitemapper because the design is already in the monitoring platform. And that's it. That's how you create a ground mount site with the TerraMax inverter using SolarEdge Designer.
All right, welcome back. It is time for the Q&A session. My name is Chris Walters. I am a technical trainer here at SolarEdge. We're going to be taking your questions and answering them live as we go through. To start with, Frank, I have some questions that came in during the webinar itself. So are there any special considerations if I'm using aluminum conductors?
So yes, they should be sized properly, of course, and then as you're preparing the aluminum conductor, you strip it back like you normally would. Use a metal brush or maybe some emery cloth that you would then clean off the conductor and remove any anodized material that's already on there. And then you would clean it with alcohol and then apply some type of an anti-corrosive coating on it and then apply your compression lug.
What parts of the inverter are field replaceable?
So there are a few parts that are field replaceable, yes. So you see these surge protection devices here on the AC side and surge protection device here on the DC side. These are field replaceable. They're a one-time use, a sacrificial device. So when there is a surge, then they need to be replaced. There are 2 fans internally to the inverter, and one is located here and the other is located there. And also behind this little door right here, there's typically a panel here. There is some fuses for the auxiliary board that is behind this little panel right here. So those are all field replaceable. On the bottom there are some external cooling fans, 6 of them actually. Those 2 are field replaceable.
All right. Are there any specific cell kits that we're supposed to be using with these? Or are there like commercial specific cell kits?
There are. So we have commercial cell kits of particular sizes for 200 kilowatts, 1,000 kilowatts, and up to 2,500 kilowatts. So depending on the size of the project that you're working on, you would order the correct cellular card that would apply to the system. And it would be installed in the leader inverter in an installation that had multiple inverters connected.
Do you have any advice on mounting the inverter?
Yes. So the inverter is 384 pounds. So it requires some equipment to lift it, like a forklift or some kind of a lifting device. And then, of course, a rated harness or strap that you would use the lifting eyes to lift it up and then place it onto the racking.
Okay. Can you tell me any more about inverter to inverter comms? What is CAN?
Yes, so the inverters speak to each other using a protocol called CAN bus. It's been around for a while in the automotive industry. It's highly reliable. And so there's no special consideration for CAN bus. It's just the inverter to inverter wiring on the communications card. We also have the external RS-485 communications that you would normally use with external devices.
Very good. All right, next up. Let's see here. Keep your questions coming in over on the right-hand side. How long does a pairing process take with that many optimizers?
Yeah, so we have a new process of pairing, a new proprietary process in our optimizers that speeds up the pairing process. So it's very fast. So our experience so far has been that it's cut that pairing process at least in half, if not even more. So very fast. It happens really quickly.
How does commissioning from the sun work?
So commissioning from the sun works when you have a number of optimizers connected already to your combiner box, and then you turn on all your DC switches and you apply the what would be power to the DC side. And however, the optimizers will be putting out a safety voltage. So the auxiliary board only needs a small amount of voltage in order to power up and start that commissioning process. And that's what does that, is the optimizers with the safety voltage of about 50 volts.
Do you have any advice for design, and where can I find design resources?
Yeah, so on our data sheet, there are, for the H1300 optimizer that is used with this inverter, there are design rules that tell you how many optimizers you can have in a string, depending on the power class of your module. It tells you minimum numbers and then maximum power per string. So that determines the number of modules and optimizers you can have in a string. There are additional rules on that optimizer data sheet that tell you how many strings you can have attached to an inverter. So the minimum in order to have your longest strings is 14 strings, and then you can size it up to 200% oversizing. So that could be anywhere from 20 to 24 strings, depending on the power class of the module and how many strings you have connected.
All right, let's go ahead and continue on with the questions. All right, we have more questions coming in. Let's go ahead and continue with our Q&A session here. Yes, the session that we did previously was pre-recorded, so a lot of those questions that came in were from our last session, but we do have a number of new questions for you, Frank. Can everybody hear me? Wonderful.
Yep.
All right. Okay, since the 690 volt AC is not a common service voltage, do all SolarEdge 330Ks require a transformer?
So they're meant to be installed in systems that would require a transformer, yes. So 690 volts is, being that it's above 600 volts, that makes it an 800 volt class inverter. So it's meant to be used with a transformer and connecting to medium voltage in most cases. However, there are use cases where you could be connecting this behind the meter. And in that case, you would need a step-down transformer that would perhaps step it down to 480 volts.
Great. And to confirm, we can use either aluminum or copper conductors?
That's right. On either the AC or the DC terminal blocks, they accept either aluminum or copper conductors.
Are the inverters grid forming or grid following?
They are grid following. So they have no black start capability, which means where they can start up and form a grid without any other external connection to a grid. So no, they cannot do that. They are grid following, so they require a grid to be able to sync up to.
Okay. Can this connect to a 600 volt AC grid?
It can with a transformer. So not with its native voltage at 690, but with a step-down transformer, like an auto transformer, you could do that.
All right. What is the difference, let's see here, hold on, between maximum continuous power per string and maximum allowed connected power per string on the data sheet?
Yeah, that is determined by how many optimizers you have connected. So, and how many strings you have connected. So, and that will determine whether the inverters, I'm sorry, not the inverters, the optimizers are either bucking or boosting their voltage or current. So in order to keep the optimizers from being in boost mode the whole time, we want to make sure that the numbers of optimizers are ideal so that it's not doing that. So that's where those numbers come from.
Who do I reach out to if I have design support design questions?
So that would be me or any of the field application engineers in your region. So we have a number of them assigned to different regions and that support different regional sales managers. So if you reach out to your sales manager, if you know who that is, and then try to get your connected to your field applications engineer that way. We also have our online support for systems that are already installed. You know, our tech support, our support lines, our call center, and also we have technical account managers that help with after installation questions and support. So we have a large support system. So for design questions and pre-sales will be your regional sales manager and your local field applications engineer.
Does SolarEdge have any regular maintenance scheduling advice? I would assume this is for things like fans getting clogged up with dust and just checking on the inverters.
Yeah, so one of the benefits of our system is that our monitoring program can give you alerts on a number of different things. For instance, we monitor the temperature of the AC and DC terminal blocks. And if they get too high, which we have found is an early indicator of failure, if those temperatures are getting too high, it alerts to the monitoring portal and alerts to you that you have to visit the site and do some kind of maintenance or check it out. We can identify ground faults and exactly where in a string things are going wrong. So our monitoring system gives us a very comprehensive, very visible view into the system and the health of the system. Your regular schedule of maintenance, either every 6 months or every year, you would check your torque values, you would do your visual inspections, making sure there's no fans that are clogged up. If the fans have failed and they're not working, that too alerts to the monitoring portal. So all of those things will help you to identify problems and know the health of your system and whether you really have to go out to the site and do any mitigation work or whatever. So your regular scheduled maintenance and then using our monitoring portal to make sure the health of the system is good.
Okay, last call for questions, folks. If you do have questions, get them in now. All right, so there's no PDF of the PowerPoint. Yes, we did not use PowerPoint for this presentation, but I can send you out a rewatch link if you like. If that is the case, go ahead and message me right now in the question box. Yes, there will be videos for installation. There will be the usual Learning Lab videos that we'll produce. We're a little bit further away from seeing these out in regular distribution, but yes, you can order them. Once that happens, you will start seeing the Learning Lab videos go out for installation. We do have a mounting and wiring video already in the works, along with all of the field replaceable videos. Let's see here, last call for questions.
I see one on the chat there. What about white papers?
Oh, yes, good.
Yeah, so that's a good question. It kind of relates to a couple of other things I wanted to mention. For instance, the 690 volt balance of system equipment. We've worked with a third-party system integrator to provide a system package solution to be able to package a 1 megawatt or 2.5 megawatt system with all the balance of system already done and integrated. So that's one thing. White papers about system design. We're going to be having additional webinars that will then lead to white papers and app notes related to optimizing your design. So we're working with a third-party company to provide a trunk bus solution for this inverter that is saves a lot on the balance of system on the DC side with combiners and string wiring. So those are some things that you can look to come out. A white paper will come out of that in regards to optimizing your entire system design. So there will be a few coming out, so you just keep an eye out for those. All right. Chris? Are you there, Chris? All right, so I think that's about all. I don't see any more questions in the chat or in the questions. So I'd like to thank you, everybody, for attending the session today. We're going to be ending the session. Again, if you have any questions, please feel free to reach out to either myself or to Chris, any of your regional sales managers or field applications engineers, and we'd love to support you in a design for these systems or to look over, review your design, or answer any questions. Again, thanks for your time. Bye.